Yes. So today also we are going to start with sp2 hybridization, but the change is today you'll be learning about where we have two or more bonds. Okay. So far now, whatever bonding I have taught you in so many hybridization, that is sp2, sp3, sp2 and sp3, you have learned only about one bond being formed. Correct? No? Due to the hybrid orbitals being overlapping, you have learned only about one bond being formed. So today you are going to learn about if there is two or more than two bonds which are being formed. Okay, how will the hybridization be? Explaining that. Okay. So the first example for this sp2 which I am going to take, okay, the sp2 hybridization, we are going to explain that in ethene molecules. I hope you know something about ethene molecules. You have even learned in your high school. Do you remember what is the molecular formula of ethene? Molecular formula of ethene. Can anybody tell me? How do you write molecular formula of ethene? Yes, very good. Correct. Ethene is C2H. C2H. What is the general formula? CnH2n. Correct, no? You had alkanes, then you had alkenes, and then you have even studied about alkynes. Okay, in carbanides compound, you had these things. Alkenes, general formula is CnH2n plus 2, correct? And alkene was CnH2n, where alkyne was CnH2n minus 2. No? So now tell me, yes, C2, eth means two carbon. Ene means there should be a double bond. Okay, so the general formula is C2H4. This is ethene molecule. Now, how to write ethene molecule? Carbon skeleton, if I take two carbon atoms are there, no? So two carbon atom, and then since it is ethene, that means between the two carbon atom there should be a double bond. Okay, so between the two carbon atom, I'm taking a double bond. Remaining carbon valency is 4. Remaining carbon valency should be satisfied by hydrogen. Okay, so remaining carbon valency I am satisfying by taking hydrogen atom. So this will be the structure, correct? So now here you see how many sigma bond and how many pi bonds are there, because we need to explain the hybridization. So before that, I will tell you here, see, you need to recall the concept of now sigma bond and the pi bond. Okay, now, wherever you find that single bonds are present, all these bonds are there, no? Single bond, that is sigma bond. Okay, so this is sigma bond, here sigma bond. Between the carbon and hydrogen, whatever bond is there, that will be the sigma bond. Now come to between carbon and carbon atom. Between the carbon atom and carbon atom, you can see there is a double bond. And if you remember, when we spoke about the difference between sigma bond and pi bond, I told you sigma bond can exist alone. Okay, but pi bond cannot exist alone. Pi bond always will exist with a sigma bond because they are weaker in nature, so they always exist with a pi bond. So between the carbon and carbon atom here, okay, one bond which is there, no students, that is a sigma bond. And one more bond you can see here, okay, that the weaker bond, that is a pi bond. Okay, so one is sigma bond and the other one is pi bond. So this is how the structure is. Now, structure is always available with us. It is already being formed. Now, seeing that structure, you are applying this hybridization concept and explaining how this structure might have been formed. So, using hybridization concept, you have to explain now how these three sigma bonds are formed and how this pi bond are formed. Can you tell me how pi bonds are formed? Sigma bond is formed by hybrid orbital. No, so that is because of hybrid orbital. So that let it be. You tell me how pi bonds are formed, how there should be overlapping, how pi bonds will be formed. Yes, pi bonds are formed by lateral overlapping, correct? No, lateral overlapping, this way overlapping. So if I have now two p orbital, and how should be that p orbital? That p orbital should be unhybridized. That should be unhybridized. You can't take hybridized orbital for pi bonding. Okay, whatever orbitals you have to take, that should be unhybridized. Means the full p orbital we should take. The whole p orbital, which should not be mixed with anything. Okay, So here you need two p orbital which should overlap laterally. Okay, like this. It should overlap like laterally in this fashion to give you one pi bond will be formed. Okay, and how many pi bond we need? Only one pi bond. So what you need to do over here is you need to keep one p orbital vacant. Okay, in both the carbon atom you will keep one p orbital vacant, which will be utilized for pi bonding. Okay, which should be unhybridized, means you are not going to use it for mixing process. Which one you are supposed to use it for mixing process now? The remaining orbitals are there. No, the remaining s orbitals and the p orbital, except one. The remaining two p orbital and one s orbital that you have to mix together. So how many hybrid orbital you will get? Three. Yes, that three would be enough, no, to form three sigma bonds. See, for this one carbon will utilize three sigma bond. Means three hybrid orbitals is required. Three hybrid orbital will be required, and one unhybridized p orbital is required for us. Okay, so you are going to mix only three orbital and one you are going to keep as it is to form the pi bond. Okay, so I will explain that about that. We will go in the next concept. Yes, we have finished sp2, and I have given one simple example for that. That was BCl3. sp2 we have finished. BCl3 was a molecule which I discussed. Now when you have two or more than two bonds where the hybridization is still sp2, that you need to explain now how that molecule might have formed that bond, okay, using the hybridization. So here ethene is one such molecule which undergoes sp2 hybridization. Okay, so let me go for that in detail. So let me start with that. So ethene, two carbon atoms are there now here, two carbon atom. Okay, so that carbon atom will be utilized for hybridization. So first you need to write the carbon atom ground state. Let me write that ground state. Okay, for ethene molecule, ground state of carbon you are taking. Ground state if I take, it will be 1s2, 2s2, and then 2p2. Okay, this will be the electrons in the ground state. Put this into the orbital. So 2s will have two electrons and 2p will have one electron each. Okay. See now ethene structure you remember. Carbon carbon has a double bond, and then we require two bonds for overlapping with two hydrogen atoms. So structure is already there. Structure is already available. Using that structure you are explaining hybridization. Okay, you need to apply this hybridization concept for this molecule and explain how this bonding might have happened. It's not that hybridization came first and then you are taking the molecule and explaining. Molecule comes first. Molecules were already existing. So you need to apply this concept now. Okay, so can I have now here this ground state electronic configuration to explain the bonding over here? That won't be possible because carbon is already forming four bond. In that, two are on this side between the carbon, and two are with the hydrogen. One carbon if I'm talking about. Okay, this first carbon you see. This carbon is altogether forming four bonds. If they are forming four bonds, that means you need to have four unpaired electrons. So this ground state electronic configuration won't help us. Okay. So what we need to do, we need to write the excited state as well. Okay. So we need to write the excited state. So when I write the excited state, this one electron from the 2s orbital, you need to shift to the 2p orbital. Okay. So let me shift that and write. So one electron you will find in 2s, and then we have one electron each in the 2p orbital. Okay. So which orbital is this here? This is pxy, px, py, and then I have pz. Okay. So I've written excited state. Why excited state has to be written? Because we need one carbon to form four bonds. Carbon has already formed four bonds. So that means that bonding has happened in the excited state, not in the ground state. Okay. So you need to write that excited state where you'll get four unpaired electrons. Okay. Now I told you here how many sigma bonds are formed. See, between the carbon and carbon atom, one is sigma bond. Then between the carbon and hydrogen, there is sigma bond. Between this carbon and hydrogen also, it is sigma bond. And one is the pi bond. Okay. So whichever is forming pi bond, no. So if they are forming pi bond, what you have to do is one p orbital you require to form that pi bond. Pi bond is where one full p orbital, okay, laterally overlaps with another p orbital. It should not be mixed. It should not be hybrid orbital. It should be unhybridized orbital. So what I need to do here, students, one I need to keep. Okay, pz I'll keep it. Okay, that I'll keep it for forming the pi bond. So this is not utilized. That means how much is required to form sigma bond? Only so many will be utilized. Okay. Only this many will be utilized. So how many will be utilized here? 2s orbital, one 2s orbital, and two 2p orbital will be utilized. Okay, to form the sigma bond. Only this you have to mix. So this is a point of focus for you. These are the things which you need to keep in mind. Okay, in the hybridization, you need to check how many sigma bonds are there. Only which is forming sigma bond, only so many orbitals are required. So 3 sigma bond is there. That means for us 3 orbitals are enough to be mixed. And one is a pi bond. So to get the pi bond, you don't have to mix them here. You need to keep that orbital as it is. Okay, this pz orbital will not be participating in the hybridization because this will be utilized to form that pi bond. Okay, so this I said you need to keep in mind, and this happens in both the carbon atom. Okay, because ethene has 2 carbon atoms, so this will happen in both the carbon atom, where one pz orbital you will keep it vacant. Okay, for both the carbon atom. So now, what are the things which we need to write here? So next point I will write about the mixing. Okay, so in both the carbon atom, you have to mention in both the carbon atom, in both the carbon atom of ethene molecule, which we need to mix here. Okay, one 2s orbital and then two 2p orbital will undergo hybridization. One 2s orbital and one 2p orbital will undergo hybridization to give how many? We will get 3. Okay, you will get 3 sp2 hybrid orbitals. You will get 3 sp2 hybrid orbitals. One is not mixed, okay, because that we need to form the pi bond. So now how to write? If it is sp2, you know it will be 3 hybrid orbital, and 3 hybrid orbitals should be arranged in this fashion. I will triangle fashion I'll arrange here. Okay, one here in this way, one, and then two, and then the third one on this side. Okay, so I've kept one over here. Another one also, this is one carbon. Okay, I'll label this as C1 carbon, and then next one also I'll take. Okay, so trigonal planar, one orbital I'm taking on this side, one over here, one more over here. Okay, so all these are sp2 hybrid orbital of carbon. This is of one carbon and this is of the second carbon. Okay, again sp2 hybrid orbital. These are sp2 hybrid orbital. Now there is one more orbital which is not involved in hybridization, so that you keep as it is. Okay, that I'll keep as it is here. It is unhybridized, means the full p orbital will be just there. See, I'll take a green one. So here I'm taking unhybridized p orbital. This is pz orbital. This is pz of one carbon, and this is the pz orbital of another carbon. Pz orbital of another carbon, which is not involved in hybridization. Only 3 has involved themselves in hybridization, because how much is required? I said only so many you are going to take. They see how many hydrogens are there and how many carbon are there which they need to overlap with. Based on that, they will combine. Okay, and if they are forming a pi bond, that means they will keep one p orbital empty, so that they can overlap with another p orbital to form that pi bond. See, I'll repeat till here. I will repeat once again. Okay, you want me to tell at the end? Fine, fine. So now see, once this hybridization is over and you find that one p orbital which has not involved in the hybridization, I have kept it as it is. Okay. Now you need to explain how many are involved in forming the sigma bond. See, if they have to form a sigma bond, see, one carbon atom's hybrid orbital will overlap with another carbon atom to form one sigma bond. So that means these two hybrid orbitals should overlap first to form carbon-carbon sigma bond. Okay. See the structure and see the hybrid orbital. Compare and then explain. See the structure first. Structure is already there. I said no. Structure is there in your hand. See that structure and then explain how they might have binded with each other. So that means if carbon and carbon bond has formed, how they might have formed. That is because of the hybrid orbital, sp2 hybrid orbital of one carbon atom has overlapped with sp2 hybrid orbital of another carbon atom. So this has led to formation of the sigma bond. Okay. Next, what is there? They have to overlap with the hydrogen atom. See here, two hydrogen atom, they have to overlap. So which orbital of hydrogen they should overlap here? And how many bond they need to form? You can find out actually. See here, One sp2 hybrid orbital, another sp2 hybrid orbital. Okay, so these hybrid orbitals will overlap with the 1s orbital of hydrogen atom. No? Hydrogen has 1s orbital. So this will overlap to form sigma bond. Another hydrogen will come here to overlap with this sp2 hybrid orbital. This side also same thing. One hydrogen atom which has one electron in the s orbital will overlap with this sp2 hybrid orbital of another carbon. On this side also same thing will happen. They will overlap. Now I've not shown the overlapping. Okay, they have not overlapped. I'm just showing you this hydrogen atom. Okay, one s orbital which contains one electron will come and overlap with the sp2 hybrid orbital. So one here, one this side. Okay, and another carbon atom also, one up and one below. So this will form. Remaining is what? This unhybridized p orbital. Okay, so when this unhybridized p orbital overlap, this two overlap, this will give rise to pi bond. Two lobes combined together will give you one pi bond. That we need to show now. Okay, so initially what I had written was only the hybrid orbital part. Okay, now we will show the overlapping also. And before that, you need to explain. What are the things you will explain? Immediately after this, hybridization is over, and you have got to know that this is how the orbital looks like. You will say that okay, one sp2 hybrid orbital of one carbon atom overlaps with sp2 hybrid orbital of another carbon atom to form carbon-carbon sigma bond. Okay, one bond we need to explain about this. One sp2 hybrid orbital of one carbon overlaps with sp2 hybrid orbital of another carbon atom to form carbon-carbon sigma bond. That is this bond. Okay, between the carbon and carbon atom, this sigma bond you need to explain. Then you go for this carbon and hydrogen bonding which has happened. That you need to explain. So how will you explain that? The remaining, see this carbon, one is utilized, okay, to form that carbon-carbon sigma bond. Now the remaining sp2 hybrid orbital, okay, the remaining sp2 hybrid orbital of each carbon atom means in both the cases. So the remaining sp2 hybrid orbital of each carbon atom will overlap actually with one s orbital of hydrogen. One s orbital of hydrogen to form what? 4 carbon hydrogen sigma bond. Okay, 4 carbon hydrogen sigma bond will be formed when this sp2 hybrid orbital of each carbon atom means in both the cases overlaps with the s orbital of hydrogen. Actually, they will overlap because it's sigma bond. No, actually they will overlap with to form the sigma bond. Okay, remaining is what? The unhybridized p orbital. So you can say the unhybridized p orbital in both the carbon atom. Okay, will overlap sidewise or laterally. They will overlap to form one pi bond. Over. Then you have to explain the structure. Then you have to finally give the structure. That's it. That sentence you need to give now. Okay. So I'll give that in the next page. So after that, once everything is over, see overlapping would look like this. See here. I've taken a picture on this side. You can see 3, 1, 2 and 3. These are 3 sp2 hybrid orbital. So these are 3 sp2 hybrid orbital, and then on the other the carbon also. This is first carbon. If you want, I will label first carbon, and this is the second carbon. Okay, having 3 sp2 hybrid orbital. This is sp2, sp2, sp2 hybrid orbital. Here also sp2, sp2 hybrid orbital. So this sp2 and sp2 which had one electron each, they have overlapped to form carbon-carbon sigma bond. Okay, this is carbon-carbon sigma bond. After that, the remaining sp2 hybrid orbital which are there on both the carbon atom, that will overlap with the 1s orbital of hydrogen. So they had one electron. sp2 hybrid orbital of carbon had one electron. Hydrogen has got one electron. They will bind to form this bond. Okay, so everywhere it happens. So total altogether we are having 4 hydrogen atom which will overlap with carbon sp2 hybrid orbital. So that will give you 4 carbon hydrogen, I said, carbon hydrogen sigma bond. Then remaining is what? This unhybridized, this green one you can see, no? Full p orbital you can see. This is pz orbital. Pz and pz orbital of another carbon atom, which were unhybridized and containing one electron each. These will overlap together. Okay, so that will give you the pi bond. 2 will overlap together. Okay, these 2 lobes will overlap to give you one pi bond. One pi bond will be formed. One pi bond. So this much you have to tell. Okay, this drawing you have to do at the end. If you find it then again very difficult, then you can go for this structure. You can see here, no, this structure which is there. Carbon and carbon double bond you put in that. One is sigma bond, one is a sigma bond, the other one is the pi bond. Here also, all these are sigma bond. Okay. Now, what geometry they will have here? See the hybrid orbital, how they are oriented. What do you think will be the geometry of this? Geometry of this will be sp2 hybridization. No? sp2 means you have three hybrid orbital. Three hybrid orbital have oriented themselves in three corners. So it will be trigonal, trigonal, planar. It will be trigonal, planar. And bond angle between each of the hybrid orbital, bond angle between each hybrid orbital will be 120 degree each. Means here, this hybrid orbital will be 120 degree, this hybrid orbital 120 degree, this also 120 degree. Okay, because these are the one which is forming that bond pairs correctly. Hybrid orbitals are the one, okay, which decides the bond angle. So 120 degree is the bond angle. Yes, now again I'll go back and revise this once again for you. Yes, now listen once again properly when you are explaining sp2 hybridization for this molecule. Okay, first thing what you will do is write the structure. Okay, for ethene, ethene molecular formula is C2H4. Write the structure. Okay, structure is this way. Between the carbon and carbon there is a double bond. No, ethene means double bond, and eighth stands for two carbon atom. So between the two carbon atom there is a double bond. Okay, and then remaining carbon valency, two valencies are satisfied here. Remaining carbon valency you need to satisfy with hydrogen. So two hydrogen on this side towards your left side and two hydrogen towards the right side. Now locate how many sigma bonds are there and how many pi bonds are there. So after writing this structure, what you get to know between the carbon and carbon atom, always I've told you, sigma bond, when there are two, okay, there are two bonds, you remember one is the, if there is two bond, one will be sigma bond, one will be pi bond, because pi bond cannot exist alone. Pi bond always will come with a sigma bond. Suppose if there is triple bond, then in that one will be sigma bond, remaining two are there, no? Remaining two will be the pi bond. Remember, if there is triple bond, okay, maximum are these bonds which can be existing. One is single bond, then we have double bond, then we have triple bond. If there is a single bond, then that single bond is always a sigma bond. If you have a double bond, okay, in that one is sigma and one is pi. But if there is triple bond, one is sigma, the remaining two are pi bonds. Okay, this you can keep in mind. And I have explained this even in the overlapping concept of oxygen and nitrogen. If you can go back and check. In that, do you remember for nitrogen we had a triple bond, and I told you there are two pi bonds in that. And oxygen we had oxygen and oxygen having a double bond. In that one was sigma and the other one was pi. Okay, so pi was formed by lateral overlapping. Sigma were formed by the end to end overlapping. Okay, so remember this concept, you remember that we have got from overlapping. So now in ethene molecule you find there is two bonds, one is sigma bond and one is pi bond. So if you want that pi bond to be formed, you need that full p orbital, which should not be involved in hybridization. So one p orbital should be kept empty. From one carbon you need to keep one p orbital empty, and another p carbon atom also you need to keep one orbital empty. Okay, so that they can overlap together to form one pi bond. You have to check how many pi bonds have to be formed. If there is more than one pi bond, then you will keep two p orbital empty. Okay. Suppose if there is two pi bond has to be formed, you will keep two p orbital unhybridized. You should not involve them for mixing. Remaining orbitals which are there of the carbon, you will use it for mixing purpose, because they have to form three sigma bond. If they have to form three sigma bond, you require three hybrid orbital. Okay. These are the primary things what I told you. Now let us go for explaining in the molecule. Okay, this is initial adjustment. What you need to keep in your mind. You draw the structure. This all these are rough work. Okay, side you draw this molecule and keep, so that explaining the hybridization will become easier. Okay, let us go for hybridization now. Okay, so first when you write the carbon ground state, you see there is 1s2, 2s2 and 2p. Okay, two electrons are there in 2s orbital, and then two unpaired electrons are there in 2p orbital. But if you take this particular state, this won't be enough, because when you write this ethene structure, you see how it is. Four bonds are there. No, that means they are forming four bond. If they have to form four bond, They require 4 unpaired electrons. So you directly write excited state. Carbon will always form 4 bonds. Okay. So you write the excited state. Excited state will have one unpaired electron each. So I've written here 2s orbital having one unpaired electron, 2px having one, 2py having one, and 2pz having one. Okay. Now out of this, how many you need for sigma? 1, 2, and then 3 you require for sigma. That means only those orbital has to be mixed. 1 you require for pi. Okay. So if you require 1 for pi, you will keep 1 empty. Don't involve that for hybridization. This 2pz, I will keep it empty. Rest everything you mix it together. Okay. In both the carbon atom, this should happen. Okay. So I told you these are the things you need to bear in your mind. 1p orbital, you need to keep it empty for pi bonding. Remaining, you will mix it for sigma bonding. Okay, because 3 sigma bonds are there. So we need 3 orbital to be mixed. So in both the carbon atom, this will happen. So 1 2s orbital and 2p orbital will undergo hybridization to give you 3 sp2 hybrid orbitals. Okay, it will give you 3 sp2 hybrid orbitals. So this 3 sp2 hybrid orbital, how will they orient themselves? Maximum distance, minimum repulsion, possible way to arrange is trigonal planar. So you can see here 3 have oriented themselves in trigonal planar fashion. This side also 3 you orient themselves in trigonal planar fashion. But I've kept them like a mirror image because we have to explain the overlapping, no? So if they have to overlap, then that means 2 sp2 hybrid orbital of both the carbon should be facing each other. So I have kept them facing each other. Okay, that is according to the bond formation. You need to face them. So this is how you need to face them and keep. Okay, and then after you draw that hybrid orbital, okay, I will draw it here if you want once again. See, one sp2 hybrid orbital, second one here, second one this side, and then third one is over here. Okay, all these are sp2 hybrid orbital of carbon atom. sp2 hybrid orbital of carbon atom. This side also sp2 hybrid orbital of carbon atom. 1, 2, and then 3. Okay, sp2. Second carbon atom. This is first carbon atom and this is second carbon atom. Okay, sp2 hybrid orbital. Once this is over, then you see how many orbital which we have not taken for hybridization, which we have kept as it is. That you will draw on top of that. See, I'll take this one. So this I have kept it as it is, unhybridized. That is pz orbital. Okay, unhybridized p orbital. Okay, pz. This you keep as it is. That is for pi bond. Okay. After this is over, now you have to make them to overlap. Which an orbital you have to make them to overlap? This one. See, because ethene structure is this way, no? So we need one bonding over here. Carbon and carbon should overlap. Hybrid orbitals should overlap because they are forming one sigma bond. So this should overlap. This carbon and this carbon should overlap. And another side you have two hydrogen atoms. So then that means one hydrogen atom should overlap with the carbon atom, hybrid orbital of carbon atom. This side also. So two hydrogen on one carbon and again two hydrogen on another carbon atom. They should overlap. Yes, correct. Every time, whenever you have to form pi bond, there should not be hybridization. You should not take them for hybridization. That's what I said. That time I told you, no, you keep pz orbital as it is. Keep them unhybridized. It is not involved for hybridization process. So here we can take pz. You are taking pz because that has unpaired electron. No, for bonding, 4 electrons are required. No, but in that 3, you are taking for sigma bond. Why you are taking 1? You are taking for pi bond. You need to draw it. No, it is there. No, carbon has no one unpaired electron. So you need to take that as it is. Take them, but don't mix them with the orbitals here. Keep them as it is to form that pi bond. Okay. So after drawing so much, after you have finished drawing so much, okay, you will make them to overlap with the hydrogen s orbital. So this two will overlap to form carbon-carbon sigma bond because between the carbon and carbon there is one sigma bond. So this hybrid orbital will be utilized to form carbon-carbon sigma bond, and the remaining 4 you can see. No, altogether it is 4, but one carbon is having 2. So the remaining sp2 hybrid orbital of both the carbon atom will overlap with the s orbital of hydrogen atom. Okay, it will overlap with s orbital of hydrogen atom to form sigma bond. How many? Four carbon hydrogen sigma bonds will be formed. Then at the end you explain about this. The remaining unhybridized p orbital of carbon atom will overlap to form pi bond. Done. Then you have to show that diagram which I have shown you at the end. If you want, I will give the writing part also. Okay, after this, I will give you the writing part as well. Yes, now your doubt is why doesn't it undergo hybridization? Because how do you get pi orbital? Pi bond, how it will be formed? See, if I have to explain about the pi bond, how are pi bond formed? You need to have one p orbital, one full p orbital, another full p orbital. This should fuse like this. Okay, when they fuse it like this, you will get one pi bond. When they fuse like this, only then you will get a pi bond. If you make them to undergo hybridization, you think the pi bond will be formed. Pi bond won't be formed. So that is the reason to form a pi bond, you need to keep them unhybridized. It should be kept as it is. Only then pi bond will take place. So in this ethene molecule, they have found that one bond is broken down easily, one bond takes time to break down. So in this, the stronger bond is a sigma bond, and the pi bond is the one which is weaker one. Okay, so this was broken down easily. So that was a pi bond, and one is a sigma bond. So if you want that pi bond to be formed, it is compulsory that you need to take unhybridized p orbital only. You can't mix them. If you mix them, then it will form sigma bond. But then that doesn't happen in this ethene. So I told no, structure is already there. You are explaining that structure using the hybridization. Yes, students, now you can write down. I will give you that notes. Okay. Step by step, I will give you. You can write down along with me. You start from here, carbon. You can write the ground state. First, you write the ground state. Okay. And write 1s2, 2s2, 2p, 2 electron in 2s, 1 electron each. Then excited state. Excited state. See, I'm writing it neatly once again because you may get confused over there. So excited state, you will shift 1 electron over here. Okay, 1 electron into S, and then one electron each over here. So you better write whatever I'm giving. That will be easier for you to explain the hybridization as well. Okay. So here 2s, and then you have 2p. 2s and then 2p. Okay. This is px, then py, and then you have pz orbital. Since it is ethene molecule, you have 3 sigma bond and 1 pi bond. So for 1 pi bond, you will take only 1 pz orbital. Okay, 1 pz orbital, you keep it empty for forming the pi bond. Remaining you will mix. Okay, remaining orbital you need to mix. So you will write in both the carbon atom, both the carbon atom of ethene 1, 2s and 2, 2p orbital undergoes hybridization to give 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. Okay, draw that hybrid orbitals. This, if you want, you can avoid once you are thorough. This diagram which I am drawing, no, you can avoid if you are very thorough with it. Okay. Otherwise, you better do step by step. Here. These are sp2, sp2. All these are sp2 hybrid orbital. Orient them with the triangular planar geometry. Maximum distance, minimum repulsion. Now remaining is the unhybridized p orbital. So that unhybridized p orbital I am taking here. Okay. unhybridized p orbital I am taking over here. Okay, pz and then pz. This is in one carbon and this is in the second carbon. So once you are done with this, then you have to explain the, see, you can explain in your own words. How will you say here? After this, after writing this hybrid orbital and uh, drawing the geometry, okay, what do you need to explain here? This, okay, this part you need to say that the hybrid orbital, sp2 hybrid orbital, okay, of one carbon overlap with sp2 hybrid orbital of another carbon to form carbon-carbon sigma bond. So one is here. Then remaining is this sp2 hybrid orbital. No, that you have to explain. The remaining sp2 hybrid orbital in both the carbon overlaps with the one s orbital of hydrogen to form four carbon hydrogen sigma bond. And then at the end, this pz orbital. Okay. So you have to explain between the carbon and carbon. First, you need to explain between carbon and carbon. Then you will explain between carbon and hydrogen. Okay, these are sigma bond. Then at the end, you tell about the pi bond. Okay? How that carbon and carbon pi bond is formed. That is because of lateral overlapping of pz orbital. So I'll give that writing part if you want here. Okay. I'm giving that in the next page. Okay. One sp2 hybrid orbital of one carbon atom overlaps actually with the sp2 hybrid orbital of another carbon atom to form carbon carbon sigma bond. Okay, to form carbon carbon sigma bond. So here one part is over. Next, what you have to explain that carbon and hydrogen sigma bond. Okay, then you will say the remaining two sp2 hybrid orbitals of each carbon. Okay, of each carbon atom overlaps actually with one s orbital of hydrogen to form four carbon hydrogen sigma bond. Okay, four they are forming. So carbon hydrogen sigma bond. At the end, you will talk about that pi bond. Okay, at the end, pi bond. So then you will see each unhybridized p orbital. Okay, p orbital, each unhybridized p orbital of both the carbon atom overlaps sidewise. That is lateral. Okay, sidewise, lateral also you can write lateral to form pi bond. To form pi bond between the two carbon atoms. Between the two carbon atoms. Okay. After that, you can draw this diagram. After that, last part is this. Okay. So, as homework, you can try for ethene molecule. Ethene molecule, you write the structure first and then try out what is the hybridization you will get. I will explain this in the next class. Okay. One more thing, students.